Good morning, everyone. I'm so glad you could join me here today. I'm going to take you on an exploration of the C++ fringe. Quite exotic stuff to be seen there. And some uncalled things do happen over there. Anyone who hasn't seen this slide yet, I suggest you take a look. Okay, any questions about it? Okay. So, a few notes to begin our morning. This talk has logging in its title. It's not about logging per se. I'm sure millions of people have done that before me. And I'm sure you know plenty ways to do file I/O and to handle logged parameters and so on and so on. But we do want to see a few new things. And the new things are, first of all, a way to encode text, encode it and decode it back again from source code without having to do any external preprocessing step. Basically, I'm not using any preprocessor other than the C++ preprocessor. The utility I'm going to talk about is called doInit. I will take you step by step through its implementation. And since I had to do it originally 1 year ago in C++ 17, this is what you will also see today. Of course, that also means it's accessible for people who don't yet have access to C++ 20. We'll have a few notes about C++ 20 later on. Short introduction. My name is Andrei Zissu. I'm very, very happy to celebrate my birthday with you guys today, so no booing allowed, for starters at least. I come from Israel. I've been programming over the past 2 decades in various sectors. Nowadays, I'm tech lead at a defensive cyber company which does automatic moving target defense, which is a novel way of doing cyber defense without actually preventing breaches, but hiding all the interesting stuff, so there's no point in doing a breach. At the time I did this work a year ago, I was working at a medical startup called binaries. Since about the same time, 1 year ago, I'm also a member of the standards committee as part of the Israeli national body. Now, I presented this last year at Core C++ and CppCon. Since then, I've made a few changes and additions. I've fixed a few errors. I've simplified a few things. Funny thing about Compiler Explorer, I originally did my slides, since I work with Visual Studio, and I also did my slides on MSVC on Compiler Explorer. As it turns out, it was only a short while that Compiler Explorer had the capability of executing MSVC code. So those slides are no longer reproducible. So you'll see new slides made on GCC or Clang, intermingled with the other MSVC slides. And there will be, I hope, an interesting discussion at the end about doing this with reflection and without macros. I wasn't successful, but I did learn a few things. So let's go to the beginning. I was tasked with what I just described. Basically, you want to protect your property, and you don't want hackers to have too easy a time. And logs are a vulnerability in this regard, because you see the text in plain text in the binary. So of course I was tasked to remove those strings. And here we have our problem. As I just described, obviously you can see in this example where the password is being checked or the license, and we don't want that. So how are we going about fixing this? Obviously, we want to replace those strings. What can we replace them with? the first thing coming to mind would be an encrypted string. That might be possible, but it's not. It's far from straightforward. Definitely in C++17, you need obviously to produce the strings at compile time. So the simpler solution would be to look for a numeric presentation. The first thing that has some usage in the industry is enums, which I see as quite ugly and error-prone, bug-prone, lots of maintenance, lots of upfront effort. You basically, for every log message, you need to have an enum mapped to to the message, and of course you gotta maintain all that stuff. Besides all the errors, I believe this will also lead to a lack of logs because, you know, all of us are lazy, as we should be. So how can we automate this? So the thing that we are going to do is to hash the strings, of course, at compile time. Now this has a few advantages and a few drawbacks. In terms of advantages, we may, of course, produce this with a const expr function, which is easy to find online, took me no more than 5 minutes. It has to be const expr and take a string and return for example, a size t as a hash. It also has security advantages, security and efficiency. It reduces the binary, assuming your average text logged string will be much bigger than 8 bytes, if we're talking 64-bit. And in terms of security, no matter the size of your log string, it will always translate to a 8-byte hash. So you can't guess at least the size of the text. In terms of drawbacks, this is a one-way process. You can't reverse it. So you don't have access to the original strings. So what's this good for? Another thing, we are producing those hashes, and hashes have hash collisions. Now here, it's a thing of both statistics and mitigation. Both are in our favor in this case. For the few months I worked on this, I didn't encounter any hash collision. Had I encountered such a hash collision, I had a mechanism in place which we'll see shortly, and I would have just needed to change my hash seed. Any collision would be immediately detected. So this is what I found online. No need to dwell on it too much. It accepts a string, returns a size t, does whatever it does, and it's const expr. Now I did a few changes here, and an addition. This is important. So now we have hash str, it accepts a string view, returns a size t, that's the hash. And here's our first log macro. And this is supposed to do away with the message. Yes?
Is this a known hash function? Does this hash function have a name?
I think on one of the next slides I have a link which also contains a short text. Okay, so if this indeed works at compile time, the message will not appear in our binary. So let's see if it worked. What do you think?
No.
Ah, damn. Okay, let's force it then. Now, if it were C++20, I guess I'd just declare the hash function as const eval, but actually that wouldn't be good because later on I'd also need to run it actually at runtime. Wait for it. So this is the way to force a const evaluation. Not much to mention here. I'm using integral constant. The expression goes in as its template parameter, so it has to be evaluated at compile time. Okay. So Now I've repeated my search in the binary, and indeed I can no longer find a password OK in the binary. So mission accomplished. Wonderful. So I have very good news. We got rid of the log strings. I do have a bit of bad news. Unfortunately, we got rid of the log strings. So we'll need some way to get them back. So how do we do that? So now we're going to talk about our decoder. The decoder is going to be a different tool, a different executable. We have a few hurdles going into this. We don't have the original strings. The hash functions are one way only. And as such, it's very clear that the production code has no way whatsoever to get back to the original strings. And the log files will therefore only contain the hashes and not the strings. So we didn't actually intend that, but we got some protection for the log files themselves, though our goal is the binary and not the log files. But when decoding this, we will need to produce the original strings out of those logs. So as I said, the production code has lost those strings forever, but lucky for us, they're still in the source code, and a different tool might get them after all. So let's say the decoder tool would somehow get access to those strings. What would it do with it? If you had the strings, you could recalculate the hashes and have a mapping, and then parsing the log file is pretty straightforward. So how do we do that? We have the strings in the original code. We have the log macros. So what we do with that? The log macros are in the places which are not invoked, most definitely not by the decoder tool. And we need to somehow collect them all. And as I said, we don't want to do any pre-processing, any external pre-processing. So what would we need for that? We would need the ability to collect all those logs somehow from places which are not being invoked, and at the beginning of time, because once we get to our main function, the decoder will already want to start parsing. So how do we do that? In order to have a piece of code be executed automatically, it's pretty clear you need to have a constructor executed. What constructor would run in a global scope? These are the two options. The first thing coming to mind would be a global object, but there is no way to produce a global object out of a local function. Maybe one day there will be with reflection, but not now. So we have static data members. Obviously, a static data member of a class has global lifetime. So we need to have a way to produce such classes from a local scope. And you might have heard long ago about lambdas, which are just an example of local classes, but they are not the only way to produce a local class in the language. So let's do it. So now we have our function with a local class. I'm sure you will allow me to say class or struct intermittently. It has a nested class and a static member thereof. And this should do the trick, will it? Why not?
You can't have static data members in a local class.
And I didn't know that, and that's a good thing. I found it out. So, what can we do now? Templates to the rescue. The template class is not local. Its instantiation is. Okay? So will this work?
Yes, I think so. You might want to put inline on my level. I'm not sure.
It's one thing.
It's implicitly inline.
I think he's more right than you, but we're not there yet. Okay. So, good news, we've built it.
It's not what we already used.
Is it?
But
Yeah,
something's missing here, right?
The line number.
Yeah, it's not doing anything. Okay. So, originally I thought this was about the optimizer, and then someone sent me an error message, my error. So, before talking about the optimizer, we need to talk about template instantiation.
Yes, I've actually used that.
So, in our case, I've instantiated the template class, I haven't instantiated the static member. And in templates, you get exactly what you instantiate in parts. So no constructor for us yet. Let's try it again. This time, I'm doing this. Instantiating the member directly. I'm ODR using it by taking its address. You'll notice the ampersand. Nope, not yet. Now this got interesting at this point, because this should have worked. So I tried to see what would happen if I actually was using something useful here as a side effect. And woe and behold, linker error.
We forgot to define the static.
So, exactly. So at this point, we finally got this to compile. That's the good news. Getting into the linker is good news in this case. So let's trick the optimizer too. Well, not exactly trick it. Inline. Although my next slides, for historical reasons, will include this form. Inline is available in C++ 17 and in Visual Studio 2019 at the time. But something was crashing when I used this form. I have no idea what. As I said, this is C++ on the fringe. Although this should not be fringe C++. Okay, so about the cast to void. This simple form tends to work even without it. But with more complex code, it starts displaying unused variable warnings, as one would expect. So we'll leave it in. So, short recap. This is where we are so far. Any questions about this? Okay.
How
Yes.
do you make sure that the output stream stuff is initialized before you log?
I was hoping for that question. Wait for it.
Okay.
I'll give you a teaser. This is why my slides don't include Clang.
Okay.
Okay. So we want. So far we've been able to just transfer a little bit of state, the line number, but we need to be able to do any custom action. So we have a name for that in C++. It's called a Lambda. So we want to be able to carry a state which contains a Lambda all the way from our local scope all the way up to our constructor. So how do we do that? Normally we would do that with the constructor parameter, but in this case it's a static object. It will only have a default constructor, so no way. And in any case, this needs to be done at compile time. So basically, we need a template parameter. So now the question becomes, how do we manage to pass this through a template parameter in C++ 17? This was the first try. The naive try. This
He's
will.
not even declared static person.
Nice, nice, nice. I see I have a good crowd here today. Okay. So next try. This works. So basically, we'll take it step by step. We have the function pointer prototype. We are using it as non-type template parameter. We can only do it this way in 17. Here's your context per bit. And yep, and the one thing I didn't mark, the last part, you know it already, line 23, instantiating the static. So now we have this. We'll talk about other compilers later. So let's say do one init. This is the one init. Now you know all its parts. Questions? Okay. So this is my promise fulfilled. Now you know how this works. You've already seen it. And this is the first contribution I got. We sent this code in C++20. Now C++20 is able to pass a lambda as a type. And then with the help of a local inline int, in this case, you initialize that int and you get the lambda executed and you don't need any nested class. So much fewer lines, although not entirely trivial. Now this got me a little bit inspired. So I said maybe there is some stuff to simplify in the 17 version too. So as I said, we still need our NTTP here, but we can adopt all the rest of this stuff. So this is still C++17. Make sense? Okay, so that was do on init. Now we need to talk about a little bit of logging. So this is what we started off with. We have basically our log macro, not much else. And now we want to build our decoder. So to rehash, pun possibly intended, the original, the stuff you already know. We have the original string. We don't have the original strings in production code. Obviously, we do have them in source code. And we have our macros. We have our macros all over the place, and as you know, a macro can have different implementations. What would that be doing? As I alluded to earlier, we would want to have a mapping from with a hash as the key and original string as the value. And we would want to do that as the first thing that the decoder tool does. And obviously we'll use do-on-init for that. So I'm going to use a compile time switch with 2 states. In actual production code, I used 3 states. We wanted to have also a state with neither being on, but I'll go for the simple way here. So in the on state, we are building production code, which is going to substitute the strings for hashes. In the off state, we are building the decoder, and we want to use do-on-init to register those hashes and their strings. Okay, and as I said, we're not going to talk about file or log parameters. So this is our basic scheme. This is where we branch off encoding and decoding. Okay. So let's see the decoder. So what we have here we have our map on the first line, which maps hashes in the form of size t back to strings. I can afford to represent those strings as const char, as char pointer, because they are hard-coded strings. Why do I need this? Any idea?
To avoid the fiasco.
Exactly. The static init fiasco. Okay, this is going to be called from do on init, so we need to do a lazy init on the global map. Now this is my safeguard. This is where I'm supposed to detect hash collisions. Of course, I need to run a debug build for this, but that's entirely reasonable, especially as we're referring to the decoder tool. So what am I checking here? In most cases, I would expect the hash that I'm registering not to be present in the map. If it is, it should represent the same string. If it represents the same string, I may identify it in the best case by also having the same address, especially if the compiler is doing string pooling. So I'm going to check that first. It's also the cheaper check. And if I have to, I'm also going to run a string compare. And if all of this fails, then I know I need to change my seed. And since this will be running on all the logs, on all our strings when starting the decoder tool, then I'm guaranteed to immediately spot any hash collision. So let's put it to the test. We have here our main function. If we are encoding, we are going to call the f function. If we are not encoding, we're basically just looking up our log messages. And how come I have those hashes in there? So that's because I've already run it the first time with the encoding, and I copied and pasted those hashes into the source, and now here they are. Here's our text. So you'll notice here this text is produced in a state in which their source is not being invoked. Okay? So this is a bit nice stuff. This I did when I still had the nested class. This is a call stack in Visual Studio. I've placed a breakpoint on the register message, and there's some nice things to be seen here. First of all, you can see on the lower left side the log message that I'm currently registering. And now if we look at the call stack, we can start walking it. Indeed, this is the text that's being registered. Now it would appear that we are inside the f function, which is not supposed to be invoked. But if you take a close look at the middle line here, you see Lambda, invoker, cdecal, so on. So we're in the Lambda. And here we would have our constructor call, and here's our global. The demo that you'll see soon and the source code, I will update it soon. For now, it's with the nested class and all that, but this is usable code. If anyone wants to scan this. Should I wait? Okay. So, no, when you discover something nice, there usually requires some special set of circumstances. You do need to have a special need, as in this case. I don't think anyone will just look for an interesting idea and let's do that. Now, this became possible, and I didn't know that, only in C++ 17, and just became possible. The reason is that in C++ 14 and prior, I wouldn't have been able to set a const expr function pointer to a lambda. It doesn't quite make sense. I mean, obviously the lambda is executed at runtime, it can't be const expr, but a pointer to it should be, at least for a stateless lambda. And yet it was not possible, so there were some language changes in C++ 17 which made this possible. As I previously mentioned, I didn't know I would have such a hard time with this limitation of no static data members in local classes. And I had issues with GCC and Clang. So my first, okay, the GCC stuff. GCC doesn't support everything you've just seen. You'll see in a minute why. But basically, it doesn't allow the lambda to be passed in this way to instantiate a template, although it should. Someone from the Israeli meetup found a solution, a crazy solution. It took me a while too, yeah. He passed the lambda type to the template because the entity P method is not possible in GCC. And then he materialized it out of thin air.
What does the comment say in the?
Yeah, should have changed it.
Can't
Okay.
instantiate.
Hack, we can't instantiate lambda, cast it from a number.
You're giving it, yeah, it's 0.
Yeah, you can put in probably any number in there.
Wow.
Yeah, so as I originally said last year, this guy is crazier than I am. Okay, now about that GCC limitation, I dug in a little bit. There is an open bug about it, open over 5 years ago by Barry. And it seems that no one's done anything about it. And Josh Lee puts it nicely. You can happily instantiate a template with a const per function pointer, but only if it points to a global function and not to a stateless lambda, which shouldn't matter a single bit, but things are as they are. Another solution that was suggested to me by Eros Strauss, I think is running C++ meetup on the West Coast. GCC seems to have a vendor-specific extension which allows you to execute any custom code in this manner. Now about Clang. Yes?
I have a question about that previous example where you're grabbing the lambda out of nowhere. Why not just make the lambda t a static member of the struct and then call it that way?
A static member of the struct.
There's
No way to initialize it.
Oh,
That came in the 20.
okay.
Yeah. Okay, so about Clang. Now it comes to, I think, your comment or one of you two about cout. I worked on this last year for a few months and I didn't realize it. And then you'll notice this is a seg fault. And then came the same guy and found my error. And that made me realize how stupid I had been. So evidently cout is an object and it's prone to the well-known fiasco. And it worked in Visual Studio. Just happened to, it didn't work in Clang. Once I fixed it, Clang is also okay. So what we have for now, we have our const expr has function, which helps us get rid of the log messages. The do-on-init implementation is based on a template class templated on a function pointer passed as non-type template parameter. It has to be const_expr, which is then executed by a constructor, which is reached via the initialization of a nested instance of the class, or in the simple form, the nested int, member int rather. And in either case, the template class is instantiated with a local lambda, except for GCC or C++20 that's done as NTTP. And we need to forcefully ODR use and instantiate that data member. And then we use the oninit to map the text hashes. So basically, we go around the limitation that hash functions are irreversible. Instead of reversing the process, we repeat the process. So once we do that in compile time in production, and once we do that in runtime in the decoder, therefore that the hash function needs to be const_expr to also be able to run at runtime. Some analysis about this. First of all, I wouldn't at the moment rush this code into production. No one has yet been able to find undefined behavior here, but well, I'm sure there is in that GCC version. But the tricky as it is, there could be some. GCC doesn't work straightforward, but the idea can be used in one of those two forms. So, lucky for us, this is mainly useful for internal tools, where we can care a little bit less about possibly undefined behavior. Worst case, we want to be able to decipher those logs, but we'll know that straight away, way before deploying the binaries, so it shouldn't really matter. And we, of course, macros are evil, but we'll have to stick with them for a while. And do an init, you need to be very careful with it. You have the init fiasco, so you can't do anything you want in those lambdas. We saw what happened with cout. I intentionally didn't take that out from the slides. As to performance, production code may actually benefit. I don't think any way it could be badly impacted. We take out long strings and we put in hashes at compile time. The decoding tool, the code base I worked on had 200 plus logs. I'm sure that's not very much, but in any case, I didn't experience any slowdown. It opened very fast.
When
Yes.
you say 200 plus logs, you mean 200 plus different log messages or 200 plus different log files?
Log messages. There is one small caveat as to production code. Many logging facilities can only accept a string. So now we have those hashes, so they will need to be converted back into strings to be logged at runtime. But since we are logging hard-coded strings, we can, inside our macros, we can just hold such instance as a static, so we do such translation only once per log message. Build times, no impact I could see. Of course, you are building const_expr code, and if you plug in a heavy hash function, then all bets are off. These are semi-smart or stupid ideas. The first one is probably more on the stupid side, but who knows? About what else we could do with do an init. the first idea was that you might have an API which would be useful to be default call as an initial call. Nowadays, if there's an API that might not be called, or someone needs to be relied on for calling some init function or whatever, this way you could have a default call from inside the declared inside the function itself, which kind of takes care of itself. Not sure how applicable it is, and it would be production code, so mind you about what I said earlier about that. The second idea might be a little bit more interesting. You could have unit testing code inside the function that you're testing. Now, you would if-def that, so it wouldn't be a part of production code, but basically the function would test itself, and that would not be a recursive call. Unless, of course, you pass in a Lambda that calls the function itself and so on. Okay. Any questions before we move on to reflection? So, this got me thinking, and this kind of it's interesting. And this week I talked at the Lightning Talk about time travel to the past. So let's time travel to the future this time. I don't entirely like what I showed you here. It's tricky code. I'm not entirely sure it doesn't have undefined behavior, and it's based on macros. So I was thinking, reflection as it stands right now, unfortunately, it needs to get unstuck. We're trying to work on that. But let's say we had a future form of reflection, which also included code generation. Could we do this in a more straightforward way and without macros? So I looked around. I found there's something called log3. It's a Clang fork. It's supported on Compiler Explorer. Unfortunately, it's more than 2 years old. It does have some C++20 support, and it supports a combination of reflection papers as they were at the time. The main one is P1240, and there are some elements especially involving code gen from other papers. So the things I need are the reflection itself plus the fragment injection. So let's see what I try to do. Reflection of this kind of reflection works in a way that, first of all, you need to do everything you're doing inside the const-eval function, because this will always have to be done at compile time. And there's something called a fragment. A fragment is a piece of code that you can inject somewhere. There are a few types of those. You could have for example, a class fragment that would be, for example, some member functions or some member variables, and you could inject that into some class. In this case, I'm using a namespace fragment, which basically just contains code. And I'm injecting it into the global namespace. So to break this down, I have, do an init, obviously, a template compile time only function with 2 template parameters, a line size, which I'll use to generate a unique name, and the Lambda that I want to execute. I'm doing a static assert to make sure that fn is an invocable object. And then I'm going ahead with the injection. So I'm injecting a namespace fragment into the global namespace. And what I'm producing is, it's a bit similar to the simplified implementation of do on init. I'm injecting a variable. Unqual ID means I'm creating a name, an entity. with the name that I'm specifying in part. So this was the object will be called dummy and the line number, which will be should be a unique name in the global namespace. And I'm initializing it with a lambda, which calls the original lambda and returns a 0 for this to work. So I'm basically creating a global object and running my lambda. So this time, I'm really creating a global object. I'm not meddling with statics and all of that stuff. I'm really injecting it into global namespace, which I see as much more straightforward. Now to the bad news. I still need macros because I need to produce the line number. And present, there is no other way. It might, I'm not entirely sure about this, it might have worked with source, what's that called?
Source location.
Source location, right? Which is a C++20 feature, but is not supported in this fork. So I couldn't try that out. So instead, this is basically similar to what you've already seen, except that it calls the, yes?
Do you also pass, in your actual implementation, do you also pass the file name in?
In my actual implementation, it's a much more complicated macro mechanism, which has obviously all the source information, file name, line number, and function number, and has parameters. I mean, the logs you're seeing here are unusable because you also want to pass those parameters in, runtime parameters, which are not hashable since they are runnable, they are runtime. So basically, the log files I produced would contain format strings. The log messages are actually format strings.
Cool.
Yes?
So could you do something like taking the do on init interface backed by the class template implementation?
Isn't that what I did?
The do on init function interface backed by, and just pass the lambda in and have the function call do the class template instantiation stuff.
That's what I tried to do. I might have missed something. I hope ideas will come up here. But I have a list of coming up about things we might need from reflection to do such stuff. So here I tried another way. Didn't quite work out. I'm not sure why. But it still has a macro, so it doesn't really matter. Ultimate result, segfault. Didn't investigate it further. So this got me thinking what we might need. As mentioned, source location might have helped. I'm not sure it would have been possible to combine it at compile time, but it might be. Another thing that would probably solve, the issue is that most ways of doing it would require me to have a unique name. That global object needs to have a unique name because I want to do many of those. At the moment, I can only do one. No, I can do many right now, but with macros. If I want to do it without a macro, I need to be able to call the const expr function, not hand it a line number, and have it do something. And if there were static variables in const expr functions, I would be able to have a counter. And that would help me produce unique names. Another thing that would go a long way, a few things actually. If I could inject a block fragment into any function. I thought I could have, let's say I could produce one single function in the global namespace. And then every time do_on_init is invoked, it would just add one more statement inside that function. No unique names needed.
It would be especially fine if that could be a const expr function.
No, it can't be. That's runtime. can't be const expr. What else might work? There's a very interesting paper, P2169, which suggests having a placeholder underline wherever you want to have unnamed objects. And the nice thing nowadays, if you underline right now is a legal name, but you can only use it once. With this proposal, you could use it as many times as you want for different objects. It would make the code ill-formed if it were used for more than one object, if it were referenced more than one time or something like that. In my case, it would make all this very straightforward. I wouldn't need any unique name. Now about, right now I'm using lambdas. I'm not sure if it would be easier, but there's also an interesting proposal for do expressions, which are a way of taking a bunch of statements and putting them together without creating an inline scope. So you could, for example, return from a do expression, it would return from the actual outer scope on a function. I'm not sure if it would be better in this case to inject a do expression instead of a lambda, but what I would really, sorry?
I don't see how a do expression would work because when it's actually run, the outer scope doesn't even exist dynamically.
If you go the way of injecting into the global namespace, if it's a function inside the global namespace, then perhaps. Let's say I were to get rid of the macros. How would usage look like?
Ideally, with current syntax, it would probably be a lambda in template parameters called.
Exactly. So that's doable. It's a little bit of a burden to put on the user. Now, right now, you call do on init and you just put in code. But okay, that's reasonable. But let's say we could get rid of that too. How do we get rid of that? You'd need to be able to pass a piece of code made up of multiple statements as a function parameter.
So how do you delimit that code?
Well, that would be interesting. I'm not sure it would be possible, but I was thinking about having one of those block fragments be buildable via perhaps an initializer list of statements, which each one of it said, I don't know, just off my head.
So with lambda, you have overhead of the angle brackets plus the square brackets plus the curly braces. So that's 6 extra characters.
Yeah.
So
it's not terrible, but if it could go away, it would be even better. Right now, we can't do that either because of the naming problem. But yeah, I'd like everything to be perfect. But it would indeed be nice. As I said, there are several kinds of injectable fragments nowadays being talked about. And, being talked about means at best probably C++ 29. But the one thing that's missing in my mind is having a way to represent a collection of statements as one such fragment. Right now, I do have to bunch them together in a lambda at best. Has anyone here done any reflection work? Yeah, it would be nice to have more hands on deck, because we're trying to get this moving. Okay, I think that's about what I had to say. I'll be more than glad for you to stay in touch. Missed the best part. Oh, there it is. Good luck and prosper. Yes.
Do you have any capabilities for formatting your strings? like concatenating strings for your log messages and
Yeah.
passing
Oh.
through.
Sorry, I forgot the actual best part, so that will be part of it. The demo. Okay. Good thing we are absolutely on time. So let's hope this works. Okay, I hope it. Okay. So right now I ran a piece of production code. Okay, this will, I hope, look familiar. I'm running two functions, which are placed here, doing this logging. I have, that's implementation details, doesn't really matter. So bottom line, so we have a log with two hashes that's just been produced. So now let's go to the decoder. So the decoder obviously has its own main function, which goes ahead, it opens an input and output file, and it's supposed to go over the encoded log and decode it line by line. And there's no hashing to be seen here, which is a bit weird. Now let's see what it's doing. So we have decode log lines, which it takes in a line as a string. The string would have a string representation of a number, a hash. So it transforms it into an actual number. And then it needs to look it up. Get message registry, you've seen this stuff. So here's the access to our map. And we're gonna locate our hash, and if we haven't located it, we're gonna write a bunch of underlines. That's nice. There is one piece missing though. Where do we fill this map? So, logger defs. This file is present on both sides. So we have our production code producing the logs, and we have the decoder using do_on_init. Both of them contain implementations of the log macro in its two forms. So now I'm going to run this. And we seem to be out of luck. However, do you see what's missing here in the decoder? It would be nice to have this, right?
It does.
You do note that the decoder has successfully built. It's just not able to decode those logs. Now let's see if dragging works. If dragging works here. Oh. Okay, let's try this again. This is issues with Visual Studio. Don't worry about it. Okay, let's do it the hard way. This had to happen, didn't it? That's weird. Okay, getting better. Sometimes I love Microsoft.
When you drink, so
Finally.
CPP.
Finally. That's Microsoft stuff. Anyway, let's run it. Looks the same. Here's our text. Just by dragging a file in. So the one thing I wanted to show you goes to your question. I'm not really doing anything with it in the demo, but it's nice to see. Where was it? Hash utils. I have a slightly different version of the hash util here. You see, it's hash strings rather than hash string. It accepts an initializer list of possibly multiple strings and just iterates over all of them and produces one single hash. For the demo, I just handed one such hash. For the production code, I did some more advanced stuff, such as taking a bunch of data and hashing it together. So I could, for example, have all the different fields of the source location and put them in as one hash. And that means that even if you have the log file in hand, and if you try to decode something, it's as secure as there are no repetitions. If you have line numbers hashing as a single value, then you'll see it pop over and over again.
Well, I mean, you're not using a cryptographic hash, so someone could find a pre-image, and depending on how much entropy you have, it might be possible to find something.
This is not supposed to be NSA proof. But it's supposed to go some way. Normally, no one bothers to think about this. Those log messages are just in there. Sometimes you have the requirement to get rid of that. At my current workplace, we also got rid of RTTI because of the same reason. It keeps code inside as names of function symbols, whatever. So sometimes this is an issue. So this is what it's supposed to address. Any more questions?
Can you do things like string concatenation in your log message? Is that what you were describing here? I didn't quite.
Yeah. The idea is to be able to concatenate compile time strings.
Okay, and so the way that I see. So the way that you do that is by passing in multiple strings, and then you get multiple hash values out of that. Okay, and so then when you log, you have you were saying the file name and the line number and then the actual log message are three hashes.
Yeah, basically what I did was take, let's say you want to have line number, some I don't know, 2 dots, what's it called, and then put in the file name, several fields one after the other. So you take all of this as one string, which includes the delimiters, and hash it. So the delimiters will also go away. When you decode it, you get back everything, including the delimiters.
Have you considered actually, before you hash the individual pieces, have you considered copying them into a single buffer of characters and then generate one hash from that?
Well, this hash is just calculating a single hash, effectively concatenating.
Remember
yeah.
Remember it's compile time.
Okay. I see. Yeah. Gotcha. That's cool.
Questions? You guys are so quiet. Okay. I guess that would be all then.
Thank you very much.